Hello again, this is Teacher Con, and this time we will be talking about geometric sequence. And specifically, I will teach you on how to determine the end term of geometric sequence. This is another lesson for Math 10. Okay, do you still remember what is a geometric sequence? We're talking about this previously. So, can you still define what is a geometric sequence? So this is it. A geometric sequence is a sequence where each term after the first is obtained by multiplying the preceding term by a non-zero constant called the common ratio. So there's something to do with multiplication. So that is simply multiplying a certain term by a common ratio to get the next term. Okay, so what is a common ratio then? Since we're talking about common ratio, what is common ratio? Or how to determine or how to find the common ratio of a geometric sequence. Okay, now the common ratio R, so that is the non-zero constant number that we are going to multiply to a particular term to get the next term. Now to determine the common ratio, that is simply by dividing any term in the sequence by the term that precedes it. Okay, so there's something to do with dividing a particular term by the term that precedes it in order to get the common ratio. Okay, so for example, this one. Give the common ratio of the geometric sequence: 8, 48, 288, 1728. Now, how to find the common ratio again? That is simply dividing that particular term by the term that precedes it. So this will be here 48, this one, divided by 8, and that is 6. Another, we can have 288, this one, divided by the term that precedes it, which is 48. So it's 288 divided by 48, and that is 6. Next, we have 1728 divided by this one, 288, and that is also equal to 6. Since we have common quotient here, and this 6 is known as the common ratio, and that is represented by R. So our common ratio for this particular geometric sequence is 6. Now, what are we going to do with common ratio in order to get the next term? Okay, let's have this question. What is the next term of the geometric sequence? 4, 12, 36, 108. So what will be the next term of 120, 108? So, to get the next term, that is, you will multiply that particular term, this 108, by its common ratio. So what is the common ratio of this particular sequence? That is 3. Since we have 12 divided by 4, it's 3. Or 36 divided by 12, that is also 3. So multiplying 108 by 3, our next term is 324. Okay, so we have that one. Next is, what is the 10th term of the geometric sequence? So not anymore the next term, but we are going to find the 10th term of our geometric sequence: 3, 6, 12, and so on. So what is the common ratio for this? That is 2. Since 6 divided by 3, that's 2. Or 12 divided by 6, that is also 2. Now, to get the 10th term, so we'll have 3 times 2, that's 6. This is the second term. 6 times 2, that is 12. That's the third term. Now, for the fourth term, that's 12 times 2, that's 24. Then 24 times 2, that's 48. Then 48 times 2, that's 96. 96 times 2, that's 192. Then times 2, it's 384. Then 384 times 2, it's 768. And 768 times 2, and that is 1,536. So that is our 10th term. Now, what if we are asked to determine the 15th term or the 20th term? Are we going to multiply up to that desired number of terms or up to that particular end term? So it's really time consuming. So what are we going to do so that we can determine that particular end term with ease and accuracy, that we don't need to multiply from the start or from the first term up to the desired term? So this time we will have a certain formula that we can help us in determining end term in as quick as possible. So that is finding the end term of geometric sequence. So given the first term, and the common ratio of a geometric sequence, the nth term can be found using this formula. Okay, this one. So this is the formula that that can help us in determining the particular nth term of our geometric sequence, that we don't need to multiply from the first up to the desired nth term. So to make it quick, so we can apply this formula, and this is a sub n is equal to first term times r, which is the common ratio, raised to the power of n minus 1. So we have this one. Our a sub n, this is the n term, okay? Or the last term, or the desired term that we are going to look for. Another, we have a sub 1, this is the first term, or commonly read as first term. These are, okay, we already know that this is the common ratio. And n, this is the number of terms. So using this formula, it's easy for us to determine the nth term of a particular geometric sequence. So how are we going to apply this one? Okay, let's have this example. What is the 10th term of the geometric sequence 3, 6, 12? This is actually the previous example, the previous problem I just presented. So if you still remember the 10th term of this particular sequence, what was that? That was 1536. And we got 1536 by simply multiplying each term by 2 up to the 10th term. So we have 1536. Now, what if we will apply the formula, the nth term of geometric sequence, this one? Okay, how are we going to solve this particular problem so that we can have this particular answer using our nth term of geometric sequence? Okay, first we will identify that the first term is 3, this one. Based on our given, our first term is 3. Next, our R. Our common ratio is 2. How did we get 2? That is 6 divided by 3. That's 2. 12 divided by 6. It's also 2. And our N is 10. How did we get 10? We are asked to find the 10th term. Since we are going to look for the 10th term, so our N here will be 10. So obviously there will be 10 terms. Okay. Now applying the formula, we have this one, the nth term of our geometric sequence, and then substitute each given information or data. We have n term now is a sub 10. Our n is 10. So we have a sub n. This will become a sub 10. Or this is the 10th term. Is equal to, first term is 3. This one. Common ratio, that is 2. This one. And our n is 10. Okay, minus 1. Simplifying, we come up with 10 minus 1, and that is 9. Next, we have 512. Where did we get 512? That is raising 2 to the power of 9, or simply that is multiplying 2 9 times. So that's 2 times 2 times 2 up to 9 times. So we come up with 512. Next, multiply it with 3. So we come up with 1536. You see, we have this answer, and look at the previous answer that we had a while ago. It's the same. It's 1536. So this is our 10th term. Okay, let's have another example. Find the 11th term of the geometric sequence 81, negative 27, 9, and so on. So using our formula, the nth term of geometric sequence, that one, we have our first term is 81, this one. And our common ratio is negative 1/3. How did we get negative 1/3? That is 9 divided by negative 27. So that is negative 9 over 27. And express that in lowest term, so that is negative 1/3. And our n is equal to 11. Since we are going to look for the 11th term, so our n here is 11. Now applying the formula, this one, n term is equal to the first term times the common ratio raised to the power of n minus 1. So substituting, we have n term now will be 11th term. So a sub n, this will be a sub 11, or 11th term is equal to, our first term is 81, times our r is negative 1/3, this one. And our n is 11, then copy minus 1. Simplifying, we have this part. 11 minus 1 is equal to 10. Okay, this part here, it's 10. Next, we have negative 1/3 raised to the power of 10, and that is here, 1 over 59,049. So how did we get this part here? That is negative 1/3 times negative 1/3 times negative 1/3 up to 10 times. So multiplying negative 1/3 10 times, we come up with positive 1,000 over positive 1 over 59,049. Next, multiplying this fraction to 81. So we have 81 over 59,049. This one. This is over 1. 81 is over 1. So 81 times 1, that is 81. And then we have 1 times this part here, that's 59,049. Okay, simplifying, we will express this in lowest term. So what is the common factor of this? That is 81. So dividing 81 by 81, that's 1. Dividing 59,049 by 81, and that is 729. So therefore, our 11th term is 1 over 729. Okay, next. Number 3. Find the 15th term of the geometric sequence where our first term is 1 and our common ratio is negative 2. Okay, we will be looking for the 15th term. So we have our formula, the nth term of our geometric sequence. So this one. Substituting with the common data, we have a sub n, or the n term will be the 15th term. N is 15. Okay. So 15th term is equal to our first term is 1. This one. Common ratio here is negative 2. Our n is 15 since we are looking for the 15th terms. Our n is 15 minus 1. So 15 minus 1, that is, okay, 14 here. So 15 minus 1, so this part will become 14. So next, you are going to raise negative 2 to the power of 14. Or we have, okay, negative 2 exponent 14, that is multiplying negative 2 14 times. So it's negative 2 times negative 2 times negative 2 and so on. So 14 times. So that is 16,384 times 1. Obviously, it's 16,384. So therefore, our 15th term of this particular sequence having first term 1 and common ratio is negative 2, and that is 16,384. Okay. Next, we have this example. Find the common ratio R. Okay, take note. This time, we're going to look for the common ratio, not anymore the nth term. So find the common ratio R if the first term of a geometric sequence is 3 and the fourth term is 192. So we are going to look for the common ratio. So since we are talking about geometric sequence, still we are going to apply the nth term of geometric sequence. Okay, so these are the data given. The information is given. First term is, we have her first term is 3, and then our fourth term is 192, and we are going to look for the common ratio. So our nth term of geometric sequence, this one, nth term is equal to the first term times the common ratio raised to the power of n minus 1. So substituting nth term, our last term here is 192. So this one. Replace n term with 192 since this is our last term for this particular problem. Is equal to our first term is 3. Okay, here. R is missing. We don't know what is R. So this is what we are looking for. So we will just write here R. Our n is 4. Since our last term is fourth term, therefore there are 4 terms in our sequence. So n is 4 minus 1. So simplifying, we have 192 is equal to 3 times R exponent 3. So we have 4 minus 1, and that is 3. Now, to eliminate 3, the numerical coefficient of R, this one, we are going to divide both sides by 3. Okay, actually this part here, we will apply the multiplication property of equality, or to make it easy to understand, to simply eliminate 3, this one. Eliminate 3 by dividing both sides by 3. So, 3 divided by 3, that is 1. And then 192 divided by 3, and that is 64. So 64 is equal to r exponent 3. Now, for this part, we are going to look for a value of r that if you are going to raise to the power of 3, we can have 64. Or simply, we are going to uh, express 64 to the fourth root, or the fourth root of 64. So that is 4. Okay, third root of 64. Third root, since this is exponent 3, so we'll have the third root of 64, and that is 4. Or simply look for a certain number that if you are going to raise to the power of 3, we can have 64. So that is 4, since 4 times 4, 16, times 4, that's 64. So therefore, our r is equal to 4. So the common ratio is equal to 4. Okay. Next is this one. Okay. Find the common ratio still. Common ratios is what we are going to look for again. If the first term of the geometric sequence is negative 2 and the sixth term is equal to 486. Okay, solution, we have first term given is negative 2. And our sixth term is equal to 486. And again, we are going to look for the common ratio. So since we are talking about geometric sequence, we will apply the nth term of our geometric sequence, and that is this one. So substituting nth term is 486, this one. Our last term is 486. So that's why our nth term here, for the second part, second step, this will become 486 is equal to, our first term is negative 2. Okay, this one. R is unknown. This is what we are looking for. And then N is 6. Since sixth term, our last term is sixth term, which is 486. So therefore, there are 6 terms in our sequence. So our N here is 6. Minus 1. So 6 minus 1, and that is 5. So just simply copy this part here, and then 6 minus 1, and that is 5. Now, we will apply multiplication property of equality in order to eliminate negative 2, or simply divide both sides by negative 2. Okay, in order to eliminate this negative 2 here, which is the numerical coefficient of r, okay, so that we can eliminate this, we will divide both sides by negative 2. So, this will be 1. Here, 486 divided by negative 2, and that is negative 243. Now, look for a certain number that if you are going to raise to the power of 5, we can have negative 243. Or simply solve for the fifth root of negative 243, and that is equal to, okay, negative 3. Since negative 3 raised to the power of 5, and that is negative 243. Okay, so then our common ratio for this part is equal to negative 3. Okay, so here we are looking for the common ratio, and then previously we are looking for the nth term of our particular sequence. Now, what if the first term or the number of terms are missing? How are we going to solve problems like this? Since we are talking about geometric sequence, still we will apply the nth term of our geometric sequence. But this time, looking for the first term and number of terms, we will be talking about that in my next video tutorials. Hope you are going to subscribe for then. Subscribe on our channel for then you will be updated in our video tutorials. Thank you, and this is Teacher Kai.